Welcome back to Pachera Talks. In previous video, we talked about the best practices of cluster security. We pick the topics, the best practices. We talked about all of these: secure access to the API server, enable threat protection, restrict access, secure container, regularly update to the latest version of Kubernetes, uh, Linux nodes, and Windows Server nodes. And then we started digging deeper in each one of these, and we finished the first one, which is enable threat protection, which was MS Defender for containers. That's how you enable the threat protection. It helps in four domains we talked about: security posture management, vulnerability assessment, runtime threat protection, that is real time deployment and monitoring. And today we are going to explore the second point, which is secure access to the API server and cluster nodes. So let's get started with the topic right here. Okay, now it is better. So restrict access to the instance metadata API. Not that one, but this one. My bad. It's the secure access to the API server and cluster nodes. So let's go one by one, all the relevant stuff that we can dig around, learn about. So let me write the topic here first. Uh, Azure AKS API secure. Okay. So this is the topic for today's video, and we are going to learn everything about it. So securing access to this API to the Azure AKS API, and along with that API, also the cluster nodes is critical. Protecting your Kubernetes infrastructure from unauthorized access and potential security threats. That's what you need to refrain, right? Because you want people who are authorized to access, right? So you need to protect your Kubernetes cluster or your cluster nodes from the unauthorized access and security threats. So how can we do that? Well, there are certain ways which will help us to do it. The very first thing is, because it's a managed service, we all know that, and we have control on the access to the API server, which is managed by Microsoft, but we can still have the control. How Well, there are multiple ways. The very first is RBAC, okay, which is role-based access control. So we should ensure what, if any guesses, least privileged, or we could say a fine-grained access control to Kubernetes resources based on the user role, which is the pillar of the zero trust as well, zero trust security framework. And whenever we talk about the security, we always talk about this. We should not give access more than they need. So RBAC, utilize RBAC to control access to the API server. Or second point, let me write this down: control access to the API server uh, in least privilege principle, fine-grained access. Okay, then we can take a simple example like uh, we should only allow developers read access to the specific namespaces where, while granting cluster administrators broader access to manage the cluster as per the role, right? If there is any auditor who is trying to audit something, he should only have the read access. And if you have multiple teams who owns different namespaces running different application to their namespaces, they should have the access to that particular namespaces, right? Then how can we make it more secure or better? Well, with the help of uh, not should not call it Azure AD, but Entra ID integration. Right? Yes, you can integrate your Azure AKS with Entra ID, centralized management of identity, single place, and easy to provide access or modify access uh, if you have that integration. So use Azure AD or Entra ID to authenticate and authorized users to the Kubernetes cluster. And well, integrate AKS with Entra ID to leverage existing organizational units and security policies as well. Because you already have all those groups and users in your Entra ID, and you can apply those roles which are available there, ready made, right? It's there. So this ensures that only authenticated users with appropriate permissions can access the Kubernetes API. All right, so that's Entra ID integration. Then we can have something really interesting. This is all about who can access as per their role. Now, from where they are accessing, like what machine are they using, what IPs they are accessing, are they in the corporate network or remote access or some jump box or bastion. So that access I'm talking about, not the role access, that is also needed. These are two different kind of access, right? So API server authorized IP ranges, rather, or whitelisting, you can call it anything you like. So restrict access to the Kubernetes API server to set off designated IP addresses. That can be done just like any other PaaS service. We have network firewall and allow only those IP addresses. You can integrate your API server as well with your network, make it a private, absolutely. That can also be done. So we can control or limit the API server access from a certain network or certain IP addresses. That should be think of. We should always have this in place, not available for all. Then network policies. We should define rules that govern the flow of traffic within the AKS cluster, because AKS cluster has cluster, then we have nodes, then we have pods, then we have containers. So they have multiple boxes inside boxes, and they're also talking to each other. Pods are talking to each other. Containers are needs information. So we should have this segmentation. We should have this traffic control in place. So implement network policies that restrict traffic between pods or namespaces. For instance, only allow traffic from the front end namespace to reach the back end namespace and block all other inter namespace communication or any such where uh, they are not supposed to talk to that particular pod, namespace, or container. You should not even allow to go there. Just like in RBAC, if you are not supposed to perform that action, you should not have that permission to perform that action. Similarly, if you're not talking to that particular pod, namespace, or maybe database or application, you should not even have the access. Okay, so network policies will help you, just like NSGs. And since we said NSGs, so of course use NSGs or firewall, maybe Azure firewall to control that network traffic outside, and network policies for the inside. This will protect the AKS cluster with additional network layer security control. So use NSG to define inbound and outbound security rules for the subnet where your AKS nodes are located. For example, block all inbound traffic except for specific management and monitoring services, right? Apart from this, we can have, I should also mention here, along with API, we are also talking a little bit into cluster nodes as well. So how could we secure node access? Let me call here secure node access. How are we securing node access? Well, we are securing node access by SSH access controls. What exactly this means? This simply means restrict SSH access to Kubernetes nodes to prevent unauthorized node access. So you got to restrict SSH access. So disable SSH access for regular users and restrict it to operations teams by using SSH keys instead of passwords, ensuring that only authorized personnel can SSH into the nodes. So this is a wonderful security practice. You should you should have that. And then, since we're talking about the access, we should also consider Azure Bastion, right? Azure Bastion, because it provides secure and seamless RDP or SSH access to the AKS nodes, cluster nodes, right? We're not talking about pod here, but the node, without exposing them to the public internet. Use the Azure Bastion. So deploy Azure Bastion in your AKS virtual network and use it to access AKS nodes for RDP or SSH through the Azure portal. Now, you're using Azure portal, and Azure portal, you should have the access to the Azure portal. You can have multiple factor authentication applied or the conditional access applied. So it is already secured from the access perspective, and eliminating the need for public IP address on the nodes because you are using Bastion. We talked about all the security aspect of Bastion just a video back in this particular series. All those security aspects is applicable even here if you're using Azure Bastion. Now, what else? Well, use Kubernetes secrets, or rather Azure Key Vault. Anything, both works, or Kubernetes secrets. It's better to use Key Vault because you get so many other or interesting features when you use Key Vault. Features of Azure, features of Azure AD, and those RBAC and stuff. But if you don't want to use it because your application is as such, then you can utilize the Kubernetes secret to store database password and API keys and references these secret in your port specification instead of hard coding sensitive information into your application code, right? That is another best practice for Kubernetes cluster. One more thing is you should always have your audit logs enable and configure for Kubernetes. Record a chronological log of all changes and interactions with the Kubernetes API server. Enable audit logs in AKS to track every administrative operation performed on the cluster. Use this data to monitor access patterns and potentially suspicious activities. It's really not good to have, but must have audit log. Then, of course, you should regularly update and patch. Regular update and patch. What are we updating and patching? Well, nodes, because nodes has that operating system, right? Ensure that Kubernetes components also and the operating system of the nodes are up to date with the latest security patches. Enable auto upgrade feature in AKS to automatically update your Kubernetes nodes when a new version is available. If you do so, but you should have a proper planning in place, right? And we will talk about that as well, because if you see, we have regularly update as a separate point to talk about. So Azure AKS API and cluster node security, these are the different points that we talk about. So by implementing these security measures, you can significantly enhance the protection of your AKS API server and cluster nodes. These steps ensure that access is tightly controlled, network communications are secured, sensitive data is protected, and the infrastructure remains resilient against potential security threats. Regular monitoring and updates further ensure that cluster remains secure against evolving security vulnerabilities. Right? Very nice. So we talked about this, and now it's time to talk about another point, which is restrict access to instance metadata. Maybe if we can, okay. Here we can, third point, restrict access to the instance metadata, right? So this is the another point for the security of Azure AKS cluster. So AKS security uh, Best practices include specific recommendation to restrict access to the Instance Metadata API. This API provides information about running virtual machine instance that can be used within application for configuration and management task. However, unrestricted access to the API can pose significant security risk as it might expose sensitive information about the underlying infrastructure to unauthorized users or malicious actors within a pod, right? I hope it makes sense. So why restrict access to the instance metadata API? If I ask you, now you have the answer. If you don't, let me explain again. The instance metadata API on Azure VMs provides data, right? Provides data such as internal IP address, network information, and in some cases, custom data passed to the VM upon creation. We type the those scripts, right? So if a malicious actor or compromised application within a pod can access this API, they could potentially gather data to facilitate further attacks or breaches such as escalation of privileges, lateral movement, or data exfiltration. Now I think you have a pretty good idea about access to the instance method. Why? So let me write it down here. Instance metadata API. This provide information of VM or cluster node about what? Like internal IP addresses, right? Then it can also provide information of network or custom data. It can provide all these information, instance metadata API. Hence, we need to put the restriction, right? Now, if attack happens, because we are going to restrict it. Why? Because if attack happens, what could happen? Escalation of privileges, which means using credentials or tokens found in metadata to gain higher level of access, and it could damage a lot more that it should not be. So that's why we need these restricted, and it can also start moving literally gathering information about the network and infrastructure to attack other components or services within the environment. So it is going with the same logic. If you're not supposed to talk to that person, you should not have the rights, no network, no access, no authorization, no authentication. Just block it, no access. So reduce the blast radius. Or it can also do data exfiltration, right? Identifying and exploiting data transport and storage mechanism. So all these things can be done easily if this can access the metadata API, because which has all those information. If one thing is compromised, it can easily get inside that environment, not just the pod, but through the pod to the Azure environment. Now, how can we take measures regarding this? The very first was we were talking about restricting access to the instance metadata API, but we can have that Azure specific settings, like Azure uses IMDS, which is Instance Metadata Service endpoint at a well-known non-routable IP addresses. Okay, Azure uses this, which is 169 dot. Okay, I can write it down. It is available on MS documentation for everyone. It is not something like I'm exposing some IP address. So IMDS endpoint at a non-routable IP address. So Azure uses this IMDS endpoint on this non-routable IP address. Now access to this IP can be restricted using network policies in AKS, right? Use network policies to restrict it. So there was a question like, how can you restrict? We know we should restrict it. Why? Because of all these points. But how? Because through the network policy. Suppose You have an AKS cluster hosting various applications across multiple namespaces. You can apply a network policy to each namespace that blocks egress traffic to the metadata endpoint, right? And how could you do that? Well, when you do something, you write YAML code, right? In the YAML code, under the spec, we have pod selector and policy type. You can write egress. Then you can have IP cider range, the one which is here /32, and block it like IP block cider. You could use that under spec. Oh, pod selector. Then policy types, then IP block cider range. So you could block easily through the network policies through YAML file. So this, right? Then what else we can do? Well, we can use network policies in Kubernetes provide a way to isolate pods from each other and from other network endpoints. We've been talking about network. Okay, okay, right here, network policies, right? So we've been talking about that. So by defining specific allow and deny rules, you can control the flow of traffic into and out of your pod, enhancing the security. So it's not just like you can block this, but you should also have applied policies that you should isolate pods from each other. If they are not supposed to talk, there should not be any possibility to talk, right? So in addition to the you all right, that's what I'm going to talk it again. So in addition to this, you can apply those network policies so that you can allow pods to communicate only with certain services within the cluster where it is the it's supposed to talk to, right? And restrict access to external resources unless accessed through a secure channel. Enable logging and monitoring of attempted connections to forbidden resources or endpoints, right? So this is all about instance metadata. So if we think about like what are the benefits we are getting out of this, well, the very first thing is restricting access to the instance metadata API helps prevent potential data leaks and unauthorized access to sensitive information, infrastructure information. So enhance security. Now, network policies offer granular control over network traffic, allowing you to ensure strict security postures based on the principle of least privilege. So granular control. And finally, uh, like regulatory frameworks, how can we forget that? Because regulatory frameworks require controls over how data and metadata are accessed and handled. Implementing these restrictions help in compliance with such regulations. So, by systematically implementing and enforcing these security measures, organization can significantly reduce the risk of security breaches and ensure that their AKS environment are secure against internal and external threats. So we're done with our 3 points, this and these two. I hope it was informative. It was interesting and you liked it. Well, thank you for watching. We'll complete the other points in upcoming videos, and there would be few more come for Azure AKS security. Because right now we are only focusing upon the cluster security. If you see, this is the source of this information. Best practices for cluster security and upgrades in the AKS. All these points we are talking one by one. And then we have another security on that we will also talk about apart from this. Okay. So, well, that's all. Well, thank you for watching, and you guys have a wonderful day. Bye bye.